So with that, I'm going to turn it over to Bruce Jenkins. Welcome to Cerner.
Thank you. Thanks very much. And I appreciate everyone taking time out of their day to come and sit in this cold room. I'm wearing my jacket because I'm a lightweight, and I don't like to be cold. So topic for today is software security assurance, and it is fun. Thank you for saying that word. I think it's fun. Certainly it's challenging, and it can be a headache at times. And you might even lose some hair over it occasionally. But I think it's an important topic. Obviously, you think it is as well, unless you were forced to come here. Was anyone forced to come here? Voluntold? No? Okay, this is all voluntary. Just want to be sure. So it's an important topic to me because I was thrust into it, and I'll get into that a number of years ago. And I enjoy it, I think, for the most part because it has to do with people and culture and attitudes, which I find today far more interesting than the technology piece. And I used to be a real hardcore techie, and I'm not anymore because I'm no longer very good at it. Things are just moving too fast for me personally. So I'm looking at it more from the social aspect and working with organizations from a cultural perspective, trying to understand why there are so many obstacles to adopting software security assurance practices. So I work a lot with customers on that. I'm currently based in Montgomery, Alabama, and where I've been for 15 years based upon my military tour. I'll talk about that in a moment. But the whole idea around software security assurance and within the organizations where we have sometimes this head bashing, in particular between developers and security, and I know we have developers in here and we have security people in here, and the question I often ask myself is, why does that occur? And I don't have all the answers on why it occurs to begin with, but I think I have some answers as to how we can work around it or work through it. So that's the reason for the title is basically sooner or later you're going to get hit by a breach, right? There's going to be a major event that's going to occur, and then there are two teams that don't always like to work together, but they have to work together as a team in order for the organization to be successful in deploying secure software systems. So just, excuse me, a little bit about myself, and I will try not to apologize too much. I have chronic allergies, and my voice comes and goes, so hopefully it holds during this session. We have a good mic, and I'm grateful for that. I joined the Air Force in 1979, probably before some of you perhaps were born. Did 28 years of that, had a lot of roles that were related to security, not formally in a CISO role or a CSO or a CIO role, by title, but that was effectively what I did based upon the various positions I had. Ended up in being involved in a breach, which I'll talk about here, and that's part of the topic of conversation. And that got me exposed to the industry. When I say the industry, I'm referring to the security industry, much more so than I had been in the past. I ended up leaving in 2007, joining Fortify Software in the professional services side, where I worked with customers on trying to understand the software security assurance challenge and what they could do to try to overcome that challenge, to at least understand better what their risks were and what they could do to mitigate those risks. I then moved over to engineering and had various other roles within Fortify, and then now HP. We were acquired in 2010. And I currently sit on the Fortify product management team, where I'm responsible for information and product security for the Fortify business unit with enterprise security products within HP software, within HP, soon to be Hewlett-Packard Enterprise. So I have three hats I wear, pardon me please, within my current role. One is to work with customers, doing the things that I'd already mentioned. What's the problem? Why can't we get through this? What can be done to improve the situation? I also work with internal HP teams on deploying our solution set, specifically dynamic analysis and static analysis, so that they, too, like you are trying to do, understand what your business risks are and what you can do to reduce those. And then I have the role, which I mentioned, I am the lead for our products. So it's my responsibility to ensure that when our products are pushed out the door, just like many of you are, that they work the way they are supposed to in the context of security. So confidentiality, integrity, availability, that's the kind of thing that I'm trying to look at. So why am I motivated to do this? It is fun, I think it is. But I'm also personally involved in this, I should say. In 2005, a lot of my data was stolen by a very large country overseas that's having some economic troubles right now, and they're devaluing their, excuse me, their currency. Excuse me. So at the time, Social Security number, name, date of birth, place of birth, security clearance information, all the jobs that I had ever had in the military, the dates of those jobs, the titles of those jobs, the locations of those jobs, information on my family, and so forth. Great information for identity theft, great information for social engineering, all gone, along with 32,000 and change others. And I'll talk a little bit about how they got into our system and what we eventually did about it. Then had a breach in 2006 with the VA. Like many of you, probably. Anyone take their work home with them? Even a little bit? Yeah, a few people take their work. So this hard worker at the VA took his work home with him. Unfortunately, it was personal data on a hard drive that was not encrypted. The data that was stolen, and along with information of veterans like myself. Then there was a reprieve, I think. At least I think there was. I think really what happened is I just didn't know, or I'm not aware that I had my information compromised. But in 2012 was next. Basically, the Thrift Savings Plan is the Department of Defense's 401k program. Information stolen, 2013, we know about Target. 2014, excuse me, University of Maryland, Home Depot. 2015, we have the Office of Personnel Management and 3 or 4 others I can't even keep track of anymore, all with my data, right? This is just my data. So I am very much motivated to help organizations try to understand what the problem is and what can be done to try to mitigate the risks associated with trying to protect our data, right, and our intellectual property. So with respect to risk and risk mitigations, any aviation fans in here know what this aircraft is? AC-130 Spectre. So this is a gunship, and that's an understatement by calling it a gunship. So this thing has a 40-millimeter cannon that's designed to turn brand new shiny tanks into charred scrap metal with a single blow. And it's got typically a bunch of 20-millimeter Gatling guns on it. So I had the opportunity to support the commander for special ops overseas when I was in the military, and I was a communications officer, a commander on the installation. I owned all comms for the base. So think a mini city with a telephone switch and all the interconnectivity that you need to run a city. From a comms perspective, I own that problem. And I got a call about 3:30 in the morning from the special operations commander, and I'll be very polite when I say that he was not happy. His data line was down. He had a line cut, fiber optic line, and it was his line that he needed to get the next morning's, actually that night, in the morning, early wee hours in the morning, mission data to fly a combat mission, to go, break things and kill people, unfortunately, because that's what we have to do in the military sometimes. So long story short is one of our, a trooper, if you will, on the base, cut into a fiber optic line. They were trenching as they needed to do, and they cut a fiber optic line, and the line went down. My backup was down as well, so we were completely without information for this person to conduct his combat missions until we got out there in the mud and in the darkness and had guys splicing optical fiber in the middle of the night. Has anyone ever tried to do that out in the desert? Yeah, it's not a fun thing to do, and we got it done. He got his mission, but my real point here is this could have been a software system, this could be a medical system, this could be the stock exchange, it could be anything that goes down for any reason, and the fact that in this case it wasn't software is really beside the point. What this is about is understanding what our risks are in all the things that we do as we go about designing systems, and then ensuring when we understand what that architecture looked like, what the pieces are that make the thing work, that if we do something to one of those pieces, what will be the net effect be? And can we afford to do that? And conversely, can we afford not to do it sometimes, as the case might be with security? So with respect to security, I would love it if someone would tell me what they think security means to them. And if you don't have a mic in hand, that's okay, I'll repeat it. Anyone care to define it? No, not today? Okay. So we'll let the dictionary do it. Here's the dictionary's definition. So basically, a feeling of being without risk, things that we do to reduce our anxiety and fear and so forth, and something that gives us some assurance of safety. So let me give you an example. I am from Bismarck, North Dakota, I haven't lived there for a long time. I left in 1979 when I joined the military. But we can still go there today, and I could take you to pretty much any neighborhood, and we could walk up to a door and see, we'd check it, and it would probably be unlocked, okay? People generally feel very safe in Bismarck, North Dakota. I'm currently living in Montgomery, Alabama. And if I go to bed and my wife doesn't remember that I had checked the doors, I have to get up and I'll go around the house and check the doors. So that action gives her a sense of security about, being able to sleep through the night, that someone's not going to come in through the door, okay? So having said that, and based on what you see here, is this a security issue to you? Based upon the definition and based upon just visual observation here. Yes, I'm getting some nods. Anyone think it's not a security issue? Okay. So anyone know Bruce Schneier? He's a security guy. He's been doing this stuff for a while. Basically, he's saying when we talk about security, when we think about security, context is incredibly important. In fact, context is critically important. So in the case of the doorknob that I mentioned, the real answer is maybe it's a security issue. Maybe it's not. It is highly context sensitive. So in this particular case, maybe this doorknob being broken is not a security issue. It looks like it's possible that this house here could just float off the edge into some ditch, potentially, or maybe the house is already so broken that someone could get in other ways. So keep this in mind as you're thinking about systems design, as you're architecting, as you're developing, and as you're testing, particularly if you're using security solutions that will tell you it thinks something is wrong from a security perspective, that context is critically important. And if you don't remember that context is critically important, you're going to end up with a whole basket of things to look at, and you're going to be lost, and you're really not going to understand what's important out of all of that. So don't get wrapped around the axle, don't get caught in the weeds. And I bring this up because ideally you're using some sort of technical security solutions, but unless you understand that they're very, very context sensitive, you're going to end up going off potentially in a direction that you don't want to go, and that's very important to talk about, and I'll get into that more a little bit later. So here is basically the agenda. I'm going to tell you about the breach that occurred while I was in the Air Force and what I helped do in order to prevent it from happening again. Then I want to talk about why software security is so hard. Part of it is because software engineering can be very, very hard. And then finally, we'll go through some lessons learned. And based upon my experiences and observations, based on my interactions with customers, and certainly based upon the Air Force effort. Excuse me. So in 2005, I'd mentioned this a little earlier, someone broke into an HR system. So it was called AMS, or the Assignment Management System. It was very well publicized, very highly publicized. Someone walked up to the front door effectively and picked up the doormat and found the key and grabbed it and just unlocked. That's an oversimplification, but basically that's what happened. So the short of it is, at that time, you could use PII to gain access to the system. You could do a reset and get a password and gain access with then the credentials of that user. And so that's what someone did. They had some PII, personally identifiable information, what we can buy for $19.95 on the internet. They got in, they used this SQL injection, and they got 33,000 records. And I have already explained to you earlier what kind of data was involved there. So we stood up a crisis action team, and I was a part of the leadership on that team. We got everyone involved from program management. We got the engineers and architects involved, the security folks, the liaison to the Special Investigations Office that we had on base. And we evaluated what we needed to do to try to prevent this from happening again, or at least shore up the systems that we had. And we looked at 4 areas here, and I'll talk through very, very quickly. These had to do mostly with low-hanging fruit kind of things, right? So password reset procedures, what are we doing around that? Concurrent account access, and I'll come back to that in a moment. System audit logs, which a lot of organizations, they sit and they run on the computers fill up, admin calls, hey, the log's full, okay, yeah, delete the log or get rid of it, whatever the case is. We're not reviewing the logs typically. And then finally, validation of privileges. That is users who have access to systems perhaps they shouldn't have access. Another organization I was in while in the military years ago, we found out that people who had been retired from the organization were still accessing the system that they had access to while they were on active duty. Classified system, by the way, or highly sensitive system. So with respect to concurrent account access, basically this means that I could log in here and I could be logging in from somewhere in Europe at the same time on the same account, and the system would let me do that. And I started investigating why that was occurring, and I talked to a few commanders who were using one of the systems that would allow that concurrent access. This is not the system that was breached. And they were adamant that that was a feature for them, because the system was so slow that when they did a query, what they would do, because they needed to do more work within that system, they would go log in on another instance and then go do some additional work while that query was running, right? So they viewed this as a requirement, and apparently it got submitted as that for some concurrent access. But obviously there's a security problem there. If I can log in from here in Kansas City, and I could also log in, say, from somewhere in China, right? So that's a problem. So we looked at those 4 areas. We changed policy actually very rapidly. For being in the Department of Defense, it was impressive how rapidly we changed policy to prevent things from occurring like the following. So you call the help desk, and they want you to be able to identify who you are. They want to validate you, and they ask you things like your date of birth, right, or your social security number or something like that, which is, again, what, PII. So we prevented that from occurring since PII is so readily available. So we moved toward things like the challenge questions that are so common today. So that's what we were up against. And then, of course, we had to develop some sort of long-term strategy. After looking at the systems, making some changes, mostly policy-wise for the short term, we wanted to look at what we could do for the long term. Here's a very high-level graphic of what this program looked like. I'm going to dive into a little bit more some of the other areas, but basically we had a breach in 2005. It took about 27 months till we got to the point where we actually had funding for this program. Now, is that a long time? Sure. Is that any longer than it should be? I don't know. You know, it's a big program, and there was a lot to do in terms of policy, culture, right, selling the right people on the idea that this is something we needed to do. But we ended up, right after the crisis action team, part of the recommendation was to evaluate products that are in the marketplace. So forgive me for the very old-looking graphic. This is not anything fancy that Hewlett-Packard might approve of, but this is, I pulled this directly out of a slide that I built in 2006 while I was on active duty. It simply represents the 6-month time frame where we ran the pilot, and actually we extended it to 11 months. And during that time frame, we evaluated about 10 or so applications within our portfolio, different programming languages, Java being very prevalent. And we used technologies that were recommended to us by external organizations. So, you know, organizations that do static analysis, for example, or dynamic analysis, penetration testing, and so forth. We ran all of our applications through that process. We made observations about how people liked using them, how they didn't like using them, what they found, what they didn't find, and we fed that information into our systems engineering process. That's what you see down there at the bottom. We did our observations and evaluation, and then meanwhile, it's like, well, oh, these technologies are finding some bad things. Why don't we see what we can do about that? So that's what's coming out the right side there is our process to then try to mitigate some of these that are in production. So our takeaways from this, threefold, generally speaking. One is, like many organizations around the world today, our software was in much worse shape than we had ever suspected. I mean, we had all kinds of IT security in place. Why would we ever look at our software? Which is what many organizations do. And that's what we did, and we were caught off guard. So this pilot program told us, hey, we've got a problem to deal with. We also realized that people don't know anything about software security. I was extraordinarily ignorant when it came to software security. Again, I was very comfortable. We had firewalls. We had all our infrastructure security. You know, why would I need to worry about these systems that are being opened right to the outside, so those of us that are in the field have access to them, which is the argument we hear today, that oftentimes we have these firewalls, so there shouldn't be a problem, but we know there is. And then finally, the situation as we saw it really put at risk our commanders that are out in the field who are trying to make decisions based upon, excuse me, what they're seeing in these systems. So when it comes to reliability and integrity, that's a tremendous problem for us. And of course, that's General Schwarzkopf, who ran the war for us during Desert Storm. And this system that I'm showing you here, basically is an accounting system for munitions. That's an oversimplification, but that's basically what it is. So if I'm a commander in the field and I need to run a combat mission and I need to rely on my personnel to access this system and tell me whether or not we can sustain a certain level of combat missions, maybe a number of sorties, dropping a certain number of bombs and firing a number of missiles and so forth, you know, I need to be able to rely on information. I'm sure you can see the criticality here. If the system has become compromised and it's either telling me more than I really have or less than I have, either way it's a problem. So you could bring that over into the healthcare industry, into the retail industry, the financial industry. Pick any industry that helps run our country effectively, and it becomes problematic for us, something that we need to think about. So from a software security assurance program scope then, after the breach, after the crisis action team review of the problem and the pilot program, we sat down and we looked at how big this was going to be for us. What do we think we could accomplish? So this is a rough sketch of what we were up against. 2,500 applications. That's known mission applications, so that doesn't include all the hobby shops that pop up everywhere all the time. You guys don't have any hobby shops here, do you? No? No hobby systems? Never, right? So 2,500 apps, all formats, right? So modern web-based, client-server, mainframe, and so forth. Any programming language you can think of, COBOL, Fortran, you know, you name it, all the way up to modern systems, .NET and Java. And then operating systems, both modern and unsupported systems. And then this included government off-the-shelf software, commercial off-the-shelf software, outsourced, insourced, you name it. We had every flavor that you can imagine. So here was our first guess at what it might look like to stand up a security team, a center of excellence, in order to deal with that problem that was triggered by this breach. So again, what I've just painted for you here is the situation that's not ideal because we were reacting. Ideally, we would be proactive in all of this, but we were reacting, and that's the reality of it. So rough sketch of what I had projected versus what we ended up with. Something that I want to point out that I think is the most important here is we were hoping that we could do 2 to 3 applications per week, and we ended up doing about 4 to 6 applications per month. Now, why do you think that is? Anyone care to venture a guess based upon your own experiences here? Why would it take so long to do a security test on an application? I've got all this great technology. All I have to do is install it and turn the handle and I get results out, right? No, that's not right? That's right. You spend a lot of your time getting the environment up just to run the test. I've got to spend a lot of time training people. I've got to spend a lot of time convincing someone that this is important. And I got to convince them it's important even though I might not fund it, right? So it's one of these unfunded mandates that we hear about often. So that's why that number is so different. And in reality, that's probably not uncommon today. I see a lot of organizations that deal with that. There are many that are better optimized and can do quite a number greater than that, but that's what we were dealing with. And here's a rough sketch of what our process looked like. We had a team that went out to an organization, a program office that was running an application, that owned an application. We spent some time training them. We then worked with them hand in hand through the assessment. That is, we would do a static analysis, a dynamic analysis with a web app pen tester program, maybe some database security if that was possible. And then we would harvest that information and go back to the office and spend a couple of weeks writing up reports. Then we would take that report and send it back to the program office. Then what do you think happened? Sometimes nothing. Yeah, if that's what you're thinking but didn't want to say, sometimes nothing. So just like any other organization, right? You get handed this big pile of to-dos and no money with it and no executive mandate necessarily, you may not do it. So based upon all that, all the planning and all the organization that we did, here are 4 items that we had in mind that we wanted to do for the organization from a program perspective. So obviously policy and governance, GRC is a big thing these days. Well, it's always been a big thing, but particularly in the government, we're policy really drives everything. That's typically why people do anything at all, is because it's of policy. We wanted to be able to educate the acquisition community, that is those who were acquiring software systems or weapon systems that ran on software, educate the operational community, so those that were running these systems, like the one that was compromised, and then incorporate software assurance into the process that where we certify a system to go live for initial operational capability. Anyone see anything missing here, potentially? We have acquisition community, we have the operational community. What about the development community? Yes. So it wasn't explicitly stated here. I think it was implicit, but I tell you what, implicit isn't good enough in what we do. We have to be very explicit. So in hindsight, I actually can't believe we overlooked that. We should have been very, very explicit about the development community, because those are actually the heroes in all of this, quite frankly. So why is software security so hard? I alluded to it earlier. And if you liked one of our former secretaries of defense, Donald Rumsfeld, here's a very famous quote of his. And I showed this in the UK at a forum last year, a security forum, and the UK folks got a kick out of it because they always got a chuckle out of Donald Rumsfeld anyway. But basically he's saying, you know, there's some things we don't know, and we don't know it. And basically what he's saying is there's a certain level of ignorance when it comes to our systems, and that isn't stating it in a derogatory fashion. That's just a matter of fact, right? There are just so many things that we don't know. So one of the things that we do know about, though, that's very complex, but the question then becomes, how do we take those things that we know about the complexity and scale that so that we can focus on everything we need to focus on? So based on this chart up here, I am concerned about all kinds of things. I mentioned earlier about outsourced software, about acquired software, about software that is done in-house. That's all depicted up here. How do I ensure that all of that is secure? And do I do that simultaneously? Do I have the resources to do that simultaneously? Or do I focus on one thing only? Should I be focusing on my production systems? If so, which applications in production? How do I determine the priority of those? What about all those Fortran systems I have that are running web front ends? And we have those, by the way. So I visited a state agency last year who was running Fortran in the back end, web on the front end, and they were using it in order to make sure that the citizens could access their entitlements or determine what their entitlements were. How do you secure systems like that? And then when they are in production, how do I monitor them to ensure that they're not compromised, or if they do become compromised, that I receive notification on that? So this isn't easy stuff, right? This is very complicated. You take out security altogether, and it's still a complicated challenge here, a complicated problem. So this chart that I'm showing you here is from GatePoint. This is from October 2014. It's actually relatively recent. 300 executives were asked what their top security challenges were, software security challenges, and these are their top answers. And of particular interest to me are these up here, the top three that I highlighted. Okay, keeping up with new business requirements and getting those applications in production. Getting stakeholders to agree. This is probably one of the greatest challenges we can ever have in what we do, is to get everyone to agree on a direction. All right, just watch our government in action right now in Congress. All of those stakeholders, and they can't seem to agree on anything, which is why we don't see a lot of progress on bills. Right? But the same thing happens at the micro level in our organizations when we can't get the right people in the room and get them to agree on a sense of direction. And finally, getting our arms around the portfolio. I mentioned that earlier. So first of all, understanding what that portfolio looks like, and then within the portfolio, which of those applications are critical to us. Here's an Osterman research paper. This is relatively new or recent as well. And I've highlighted here what I think is important. You know, security is important, but so is the requirement, and how do I balance that? And that becomes a challenge for all of us. So where are we at now? Why software security is hard. So all those complexities, here's another important point. I was interviewing a security consultant a number of years ago. This person was very sharp. They were a top-notch engineer. They were mostly through the process to the point where we were going to make an offer, doing some final interviews, and he said, I don't want to do security, I just want to be a programmer. Okay? So I wasn't happy, right, because I felt like my time was wasted. On the other hand, it gave me some new perspective on developers and how they view the world, or at least how I think they should be allowed to view the world. And I'll talk about that a little bit more in a moment. But basically, software developers are not trained to be security experts. That adds to our challenge of trying to develop secure systems. So I want to talk about, this gets back to the whole, the partners that seem unlikely, and that specifically has to do with the security folks and these development teams. So I want to talk through 4 areas here very, very briefly: awareness, education, training, and issue management. I'll talk a moment about what I mean by issue management. And then source integrity, and I have 2 meanings for source integrity. So first of all, with respect to software developers, we know that awareness is a challenge. And if from a management perspective, if awareness is a problem, it's my fault, okay? Sorry for the managers in the room. Whenever there's a problem like this, I always blame the manager, because in my opinion, the manager should take responsibility and ensure that his or her team has the awareness necessary to effectively make decisions. So typically, developers don't know about these security issues. They don't know that it was a requirement, whatever it is we're talking about, pick a topic. From an education and training perspective, they're often not trained to fix it. Any of you software engineers in here learned security in college when you went through? Oh, we have 1 hand. 2? Okay, 2 or 3. That's pretty good. It's still, though, a small percentage of this audience, which is not a good thing, right? But it drives home the point that typically when we go through school, we're not trained on this. We're not trained on security. So they don't know. From an issue management perspective, historically, we'll have someone in security just hand a pile of findings to a developer or a development team and say, here's all your problems, go fix it. And we could talk all day about why that isn't a good thing to do. And then finally, from a message integrity or source integrity perspective, developers often view the security team as not knowing what the heck they're talking about, right? Or is that not the case? Security team always knows what they're talking about? Always, okay. So this is a problem, and I see this in every organization, right? And this should not be a surprise to you. I'm sure you've either seen it or you've experienced it yourself. From a security viewpoint, we have awareness, okay? From their perspective, these are common issues, right? Everyone knows about this stuff. Why don't you know about this, okay? From an education and training, they don't know how to fix it necessarily, but it's not their job. It's the developer's job to fix this stuff. Security's job is to point it out, right? To find it and to bring it to you and say, okay, you need to fix this. And then the question becomes, well, why can't they fix this? What are they doing back there? Why does their code look so bad? You can't trust those developers anyway because they're sneaky, because they're smart, and they're just going to try to work around all of this, okay? So this is part of the reason I think, from a cultural perspective, we end up with a lot of headbutting between software development teams and the security teams, and that is a major problem for us. So based upon all those things, what can we do moving forward? Again, this is based upon some of my experiences with the Air Force. It's based on a lot of my experiences in professional services, working with organizations, and directly while I'm pro services, and on my current experiences in working in organizations within Hewlett-Packard and outside of Hewlett-Packard. So one is, of course, the security team has to be at the right level in the organization. So what this is intended to depict is that the Center of Excellence that was stood up, that's the SACO, stands for Application Software Assurance Center of Excellence. When we stood it up, basically it was buried fairly low within the hierarchy of the U.S. Air Force and the Department of Defense. That doesn't necessarily have to be a bad thing, but in this case, in my opinion, it wasn't as effective as it could be if that authority was much higher in the food chain, right? Because the higher in the food chain, typically they carry a bigger stick or have more implied authority, you name it. Either way, this is where we were, so the idea is if you're going to have that authority, make sure it's somewhere in the hierarchy of the organization where it makes sense. And you have to have a mandate. There is a very clear need to have the mandate come from someone who has also a vision. So someone in the C-suite who understands the problem, and when I say that, I don't mean understands that we have SQL injection in our code. What I mean is understand that our software systems have risk exposure and that we as an organization must do something about that risk exposure, and then he or she is an advocate to fund that and to identify the talent in the organization or from outside the organization that can help with that problem. part of what we did in the Air Force when I was working through this as well is we were typically paying attention to the people who were raising their hands and say, yeah, we'll sign up and we'll do this, which is well and good. But what you really need to do is kind of look at the people who are not raising their hand in the organizations and figure out why they're not doing that. And if you have the resources available, you pay attention to them and you focus on them. Further, when we talk about requirements, and I mentioned this, or it showed up in those charts that I showed earlier when we're talking about, I'm concerned about new requirements. I want to, I have a challenge in getting my business systems into production. What ends up happening is we focus our attention on these new requirements so often because a customer needs them, or we promised it by a certain date, and now we have to, kind of scale back on what we're trying to do around security. And then finally, if you have the mandate, and that mandate is at the right level, you can make a bigger splash in the organization. So, next up, goals and objectives. I'm going to run through this pretty quick here on this slide because I'm going to run through it in much more detail in several slides. So, short story here is when we're using technology to help us find problems, we're going to get a lot of problems, at least perceived problems. Recall the slides where I talked about context, right? We don't want to get lost in the weeds or get wrapped around the axle. We use these technologies, we're going to find a lot of problems. How do we cut through all that, okay? So the way we cut through all that is to identify something way above that that's important to us in the organization. So this is a quote from Dave Packard, one of the founders of Hewlett-Packard, and basically what he's saying is in order for us to move in that direction together, we have to have a common vision or a common goal, right? And it has to be very, very clearly stated to the organization. So from the perspective of security, what I've done here is up on your left is Hewlett-Packard's corporate objectives. These are publicly available. And in the middle are all the organizations that are between me and corporate Hewlett-Packard, if you will. So we have HP Software Organization, we have Enterprise Security, and then we have my business unit Fortify, and then we have me and the security group. So from a context perspective and a goals perspective, in order for me and my team to focus on what's important, I'm going to pay attention to my business unit and the goals of my business unit. Okay, what are the business unit goals? They're enumerated, 1 to N. Okay, based upon these goals, what can I do from a security perspective to support those goals? And I'm going to create some security goals, and I'm going to anchor myself to those. And the idea is that if I'm doing something in the trenches, Sally programmer's coding away and she's wondering why she's having to do that or wondering why someone is having to collect statistics on defect density based on security, what we should be able to do is trace that all the way up to the highest levels of the organization, in this case to something along here from the corporate side. So that's the concept. And so the idea then is to identify that mission within your organization. Again, this should come from someone high up. The executive should be driving this. It's got to be at the right level. You create some goals, and then you develop your security strategy based on those goals. So installing static analysis in software development process is not a goal. That's like a milestone on some project that's part of a much larger program. Okay, that's a task that we have to do. That is not an end goal. And I bring that up because so many organizations that becomes a goal. Hey, what's your security goal? Well, I need to acquire some dynamic application security testing products and get them installed. Well, and that's not a person who's a programmer or a security architect talking about that. That's like a VP or director level saying something like that. So my argument is that's the wrong approach, and the right approach is to think about strategically what our goals are, and then we tie our security strategy to those goals, base our priorities based upon those goals and our business risk. So get a handle on the portfolio, first of all, as we know we need to do, and then within that portfolio, I know I can't fix everything at once. In fact, it might take me years to fix everything. So based upon my portfolio, what are the most important or mission-critical applications? And then within those applications, what is important to us? And what is important to us? Well, we go back to our goals and objectives and figure that out. And then once what we want to do is measure that, so identify metrics that directly support the objectives, which support the goals, and so on and so forth. Seems very simple, and quite frankly, it is very much Project Management 101. I do a lot of talking about this, and I have people say, I learned that in my first year in college. And I was like, okay, so why don't you practice it in what you're doing right now? And that's the truth is often we can't do that because we become overwhelmed by many other things. So another lesson learned, awareness, education, and training, I alluded to this earlier, complex problems, complex solutions. Everyone in the organization, first of all, needs to understand what we're dealing with. So in the case of the Air Force where we had the breach, it doesn't do me any good to only tell the people that are involved in developing that system that we had a breach and what the problems are and what we need to do to fix it. We need to be telling the entire organization, hey, we are at risk. We have people that want to attack us. We have people that want to steal our data. We need to develop a strategy to protect ourselves against that, okay? You have to let everyone know. It has to do with those awareness campaigns that many organizations engage in to make sure that everyone, from those of you in the room to our administrative assistants, to the person who is part of your organization but maybe serving lunch line in the cafeteria, understands that when they're sitting at a computer, security should be forefront in their minds. And bottom line here, in this case, is no education or training. Ultimately, you're going to be left with unmet expectations. Next, we need a clear communications line regarding security. I've already mentioned that, touched on it, I think probably enough. It has to be tied to policy. You have to set the expectations. I work with some organizations who feel that very strongly that they try to motivate their developers, as an example in this case, by giving them bonuses based on performance. So, in other words, low defect rates, low security rates, they get bonus for that. I don't quite frankly know how that plays out. I don't believe that engineers are as coin operated as, let's say, a salesperson might be in that regard. But if it works within the organization, if your culture supports that, you should try to do it. And then consistently enforce those policies. In other words, if we establish a policy to create some sort of a security control, you have to ensure that that's enforced in all possible ways. And then next, software security is a unique skill set, and I'm wrapping this up here. So historically, in our line of business, we focus on the network. We're safe. We have our firewalls. We have our intrusion prevention. We have our intrusion detection. Yet we're getting compromised all the time, and it's because we're only thinking about that safety net from a network perspective and not thinking about the risks associated with our software. A note here about that aspect and that trust we place in the network is the fact that these folks are not trained in software engineering and software security. Development background is necessary, I think, so for those of you who are software engineers and you are interested in security, I think that's a critical asset. It's much easier to take someone who is a security or an engineer, a software engineer, and make them a security person than to take an IT security person, and no slam against IT people. I was one and I managed a lot of them, and then try to make them a software person. That's a much harder angle to try to attack. And then, again, even with the development background, extensive training and experience is needed. And I really want to foot stop this one. Developers, you in this room who are coders, should not be expected to be security experts. You should be expected, though, to implement requirements, as I think you are. And it's a point I really didn't make earlier, that requirements ultimately have to become part of this process. So, summary, and I've mentioned all of this already, we in this business, first of all, can't do it ourselves. We have to have top cover. We have to have executive sponsorship. And then once we get it, we have to work to maintain it. And I argue very strongly that the only way to maintain it effectively is to establish a security program that has goals that are directly tied to the business, right? Goals that are directly tied to the business. If I have these random security goals, we have a bunch of cross-site scripting we need to eliminate. That's our goal for 2014. As opposed to our goal is to support directly one of the business goals, and I gave some examples with Hewlett-Packard there. That's a much more compelling argument to keep the attention of someone in the executive suite. So develop those security goals, strategy, objectives, make sure folks are trained. There's a lot of controversy around training today, whether or not it's effective. I argue it can be effective if done right. And when I say right, that's all context sensitive again, to use that word, right? It's based on your organization, based on the culture. Do what's right for you, but my point is if you have expectations of someone to perform, you have to train them to give them the skills so that they can perform. And then put security issues, let me back up, use technology appropriately. Again, I'm going back to the point I made earlier. These technologies, these dynamic analyzers and the static analyzers, come up with tens of thousands of findings, okay? Once we identify which of those are legitimate, you need to take that and put it into your defect tracking system, right? Don't just look at all of them and say, well, I have 50,000 issues, I need to fix them all. You need to evaluate them because those analyzers are very noisy. And once I narrow that down to a list that's legitimate, you need to put it into a defect tracking system, whatever yours is. And why do I want to do that? Because that's what is fed to the development team, is what's in that system, right? So it has to do with the whole idea of making it part of the regular workflow as opposed to bolting on security. And then finally, you want to have a program that's measurable, and it can only be measurable effectively, in my opinion, if it's based upon objectives that are tied to goals, that are tied to the business, okay? Not just some random metric that someone wants to collect. And you want to report it. If you're collecting it, you need to report it. So I find often that organizations, once they do collect the data and they say, this is terrible, I don't want to report this because I don't want my manager to know about this. But you have to have full disclosure here. That's the only way you're going to move forward. And then finally, if things aren't working, you make adjustments. So big breach in the Air Force. I got my data stolen. I became very interested in security. I had a lot of experiences and fun working with organizations on trying to understand the security problem. It is not easy by any stretch of the imagination, and it relies almost entirely on you to get the job done. But in order for you to get the job done, you have to have expectations set, you have to be trained, and you have to have an executive at the right level who is sponsoring your security activities. And I'll say again, not requiring you or expecting you to be a security expert per se, in my opinion. If you're a developer, you implement requirements, and what I want to do is take the security issues and make them part of the normal requirements process. So I think that's it. I'm well at my time ending. Do I have any questions? Yes, sir.
When you were with the Air Force, what sort of education did you pursue? Because you had mentioned that part of the successful rollout of the security program involved educating developers. How did you educate your developers?
So we had a combination of computer-based training, which was a very small part. The greater part was actually hands-on classroom instruction training. What's security? Why is this thing we call SQL injection bad? What is SQL injection? I worked with a database programmer. He'd been doing it for 30 years. He had never heard of SQL injection. That's not bad. He just hunkered down in doing his business. It's just a matter of fact that people get involved in what they're trying to do and don't understand it. So hands-on instruction, what is security about? And then just as importantly, what are the technologies that can help us identify risk in our software? How do we use them? And then how do we evaluate the findings? Because anyone could plug in a static analyzer, turn the handle or pull the handle, get some output. Well, then now what do I do with that? As I'd mentioned very early in this presentation, there's a lot of output. It's very noisy, but what do I do with that? So a little bit of computer-based training. What's security all about? What are the technologies that are available that help me find these issues, and then what do I do with them? That was the net, coverage or the effect of the training that we did. Now, in hindsight, though, we didn't make it, at least at the time, and so I'm speaking about many years ago, right? 9 years ago. This was 8 years ago. It wasn't a recurring training, so we'd come out and do a one-time training. So what I advocate today, what I think, and if you've got an HR organization, you get the email once a year and saying your sexual harassment training is due or what have you. That's the kind of level of training we need in an organization where if you are a software developer and you're a Java specialist, that come some annual time frame in August, you have to take a refresher course on security vulnerabilities that are present in Java code. Did that answer your question? So,
yeah, I was curious if you staffed the training from inside the Air Force, or did you have to bring in external?
Yeah, it was part of a contract. So I mentioned in one of the slides, it showed the number of people we hired effectively that were outside the organization that weren't organic. So these were security experts that we brought in. So we would go to a business unit, if you will, in the Air Force. We would train their staff using these external experts, what's security, how to use the technology, what to do with the findings, and then we'd press on with the assessment. So that was that's painting a picture of what the security program was at the time. That's not necessarily how I would advocate it today, but that's what that was back then.
How would you advocate today?
So how I would advocate it today, as I'd mentioned already, right? So you make it this recurring program. It's role-based, whether you're an architect, a developer, you're a risk manager, you're a dev lead, you're a VP of engineering. So based upon your role, there'll be a required set of trainings that you take. Which trainings? Well, the question is, what are the goals and objectives? Because that determines what trainings I'm going to need so that I can achieve those goals and objectives in any given time frame. But it's role-based and it's recurring, and the training is not based on randomness. It is based upon what the goals and objectives are of the organization at that given point in time. Okay? Another question? Yes, sir.
Hi, I was just wondering how you became aware of the data breach that happened while you were with the Air Force.
We were advised that there was very unusual database activity. That's how we figured it out. I'm not sure we would have known otherwise. But, we had monitoring systems in place, and someone observed that there was unusual data being taken out of the system. And then we called in the authorities and the special investigators, locked down the system, and did the forensics on it, and had full discovery. Any other questions? Was that helpful to you? Did it cover some things that maybe were interesting, or at least had caused you to think about it in a different way? Okay, so I ran a development organization a number of years ago. I didn't talk about this in my history, but Air Force Wargaming Institute, then it was called, in Montgomery, Alabama. And I ran Dev and Ops for a while, so I had a bunch of software engineers working for me. Very high maintenance, right? I'm having fun here. Very smart, right? Very smart. And it's a tough work, right? Because software engineering is, in my view, kind of this aspect of hard science and creativity combined. And the big question is, how do you harness the creativity in an engineer in such a way that you keep them happy, right? But also are effective for the organization in getting done what you need to get done. It's not an easy thing to do. And then you add security to all of that. But without our software engineers, we can't get anything done. But we just can't make them security experts. And I think that's the problem we have today, excuse me, in some organizations, is we're expecting our software engineers to be security experts, and we should not be making them security experts. We should be taking these security requirements and then building them into the system and then training you how to satisfy that requirement, not to identify the security risk and how to mitigate that risk. You can't spit it out. Okay? What else? Anything? All right. Well, I appreciate your attention.